Hello there, ladies and gentlemen. So in this episode we'll be basically doing per layer animations. So as you can see, here is layer 1 animation. If I switch to layer 2, I don't have any animations set here, and then if I switch to layer 3, for example, we just have blinking lights. Now this is different from the RGB matrix effects that you can find on the QMK firmware. This is because to enable these RGB animations using this way, you would have to disable the per layer RGB, and which is fine, I guess. You can set up a key to basically toggle between layer RGBs and animations basically, but what I wanted to do was set up so that you can still toggle between layers and you can still have the animations running. So you can like disable the animations using a key here, enable them, increase or decrease the speed of them. So this is like the fastest one, and then you can see here at the top you can also program these to also display. So when I turn on the animations, you can see there's like a nice animation there. And so yeah, this is just basically using custom, we'll be writing custom per layer RGB functions basically. So the easiest way to get started with this is, I should mention that I'll be doing this specific for ErgoDox. Other keyboards, they handle animations a little bit different, which might result in using a kind of different way of doing it or whatever. But anyway, the easiest way to get started is to quickly create some layout here, and make sure you also have like per layer color, and then assign some colors as well so it'll be easier. And if you want, you can also, since these guys introduced macros, you can enable some macros. You don't have to use them, but what this will do is it will generate some code, so we won't have to type it out, you know. We can just add to it, so it'll be faster if you just like quickly added a macro. Another thing is if you add a reset, so add a reset key here as well somewhere. This basically allows us to like reset the firmware without needing to plug or stick like something inside here. We can just like press the key and it will basically do the same function as that. So once you put in that key and then put in some RGB and all that kind of stuff, what you want to do is compile the layout, and then what you want to do is download the source. So what this will give you is a keymap. So when you download your QMK firmware from GitHub, so just search for QMK. So just clone or download that, set it up in here. This is a Linux tutorial, by the way. If you're on Windows, just set up a virtual machine, it'll be easier. Once you have set up this, inside here there is a util function, and just do Linux install, and this will install all the packages we need to build the QMK firmware. And then what you want to do is head over to keyboards, and on my version here I just have the ErgoDox, so I'll have a GitHub link to my fork of the firmware, so you can download this if you want, and the code that we'll do in this video will be up there as well. So head over to ErgoDox-Ez and keymaps, and then copy what you downloaded from here into keymaps. Now what I'm gonna do is this is my LED keymaps, basically the one that I'm using here. And so before I figured out how you do the LEDs, I was actually using this one. No mouse means I just have like the mouse disabled, since I don't use the mouse functionality on the keyboard, and it saves some firmware. So I'm just gonna copy this and I'm gonna paste it here and just rename it. No mouse. I'll just call it YouTube or something. So rename that. Alright, and then you can open up this folder inside your code editor. I am using just the Visual Code. It's not Visual Studio because there's no Visual Studio for Linux yet. And so the folder should appear here. There it is. So you'll have, if you don't have these 3 files, I think you should, but anyway, just open them up. Now I do have some changes made here inside the config header. This should all be what you have, so this is what the ErgoDox generator puts in. And then here is what I put in as well. So what this does is it disables like some stuff that we don't need, and disabling all this also frees up some space in the firmware, so it's handy if you do that. Force N key rollover is basically, you know, the N key rollover, so you can press more than 5 keys or more than 6 keys at the same time. And then all of these here are the RGB effects. Since we'll be doing things differently, we won't be using like the RGB effects per se, we'll be customizing the layer effects. And then the rules.mk, this should all be default. Make sure you have RGB matrix enabled and RGB light disabled, but this should be how you have it as well. And then for the for stuff here, so you can see stuff I added. Basically I just disabled a bunch of stuff, so like the mouse keys, the extra, I'll actually zoom in here. So like the mouse keys, the extra keys and all that kind of good stuff, I disabled it. I enabled the N key rollover. Now disabling all this does free up a good bit of space. And then the keymap.c. This is where we'll be writing all of our code pretty much. Now you won't have these. This is just, I made these kind of shortcuts. You don't have to worry about these. And you don't have to worry about these as well. And then if you put in macros, your macros should appear here. We'll actually be adding stuff in here, because this is basically custom keycodes that we can program. So you can set them on your keyboard and they will allow you to like do custom functions such as enabling the animations and stuff like that. Now here is the key maps. Now your ones might be a little bit messy because I just took the time to format these. And again, make sure on some layer that you have the reset key here. So this will make our lives a little bit easier. For you, default, these will probably be named like this. It'll show up like this. So to change that, what you want to do is just define layer. So layer 0 would be your main layer, layer 1 would be your symbols layer, whatever. Layer 3 have my macros layer, and layer 2 macros layer, and then the final layer is the gaming layer. So this way it's just easier than remembering the numbers, but it's exactly the same. So if you go down here, you should have all of this as well. That comes like built in with the firmware, so that's why, or built in with the ErgoDox configurator, so that's why it's handy to download the source code from this. You won't have these. This is just, I replaced all of all of these with basically words. So these are the colors. These are the per layer key colors. So on your one, instead of like the words, you'll have a bunch of these basically. So if you want, you can do something like this. This is, by the way, in the format of hue, saturation, and whatever the last one is, value or something. It's a little bit different from RGB. As you can see, I have converted them to RGB so that way we can know what's the story. And yeah, so that's just the colors. This is the function that sets the layer keys, or the layer colors. So we'll be making a custom one of these, but we'll also be using this one when animations are disabled basically. Yeah, so this is the function that actually sets up the layers, the layer colors. So as you can see, if we're on layer 1 or layer 0, it will set the color for that layer. So that's how that works. Process record user, this is all the macros basically. So if you set up any macros, you can access them here. Now another thing is this configurator, by default, it puts in delays here. I don't know why they have delays, but that just means that your macros type out like relatively slow. So what you can do is just disable all the delays and stuff like that. So yeah, and then at the bottom here, this is the what you call it, this sets the mini LEDs here. So before we do anything, we'll actually flash the firmware. So to flash the firmware, you would do a make inside the firmware directory. So make sure you're there. And then we're gonna do ErgoDox and the folder name basically. So as you can see, we're gonna be using our mouse YouTube, like so. And this should compile properly. Yeah, so there we go, 71% used, which is pretty good. So then what you want to do is open it up inside your Teensy. So this is what we're going to be using to flash. It's the Teensy loader. Set it to auto mode and then open up your firmware here. Go to your QMK folder where you cloned that and then select whichever one you're building. Open it up, and then on the keyboard just hold down this, and then I use the reset key here. So just press your reset key wherever you want, or if you don't have that, just stick a pin inside here, it'll do the same thing. And you should see some output here. So if I just run it again so that you can see, you'll have a box programming and then it'll reboot. And so as you can see here, if I change layer, you will see these LEDs here. Now I actually don't like those. So the first thing that we're gonna do, we are going to disable all of this. So just highlight all of these and then you can just delete it. So save the firmware and then make it again. So make sure you do make clean, which will delete the build directory, which will have old files from the previous firmware. And then just do a make ErgoDox and then your folder name basically. Alright, and then just flash your firmware again. And now, as you can see, when we change layer, we don't have any RGBs present. And when you turn on your keyboard, you will see a LED animation here. Now I have set up a custom one. So if you want to do that, I'll quickly show you. It's fairly easy. Is inside your keyboards folder. So close down the key maps and go to ErgoDox-Ez.c. and scroll down until you see ErgoDox blink all LEDs function. And you want to create a custom function here, which is this one. And as you can see here, we first of all need to comment out all of these, because we'll be running those inside our function basically. Then comment out all of these, and then at the end make sure you leave ErgoDox LED all off, because we don't want them basically still running. And so first of all, when you will turn off all LEDs if there is any, then we'll set the LED brightness to whatever this default value is, and then we turn on the right LED. Now right LED 1 is basically the one that's furthest to the left, 2 is the next one, and then 3 is the last one. And then we do a delay of 50 milliseconds, so that way there's like a, you know, an animation, they just don't turn on really fast. And then we want to turn it off, do a delay, turn the second one off, delay, third one off, delay, and then after that it's just backwards basically. And so when you got all that done, when your keyboard starts up, you'll have a custom like startup LED animation, which is pretty cool. So that's just like a quick thing we can do. That's pretty cool. And then we aren't gonna touch this file again, pretty much. So anyway, next thing that we want to do is we want to create a function. Here, this is a predefined function. We are just gonna put it above the RGB indicate user, because we'll actually be replacing this function. So what this function does, as I told you before, is it changes the layer colors. But since we want animations, we will actually need to use a function which is predefined, so make sure you call it the same way. So this is the matrix scan user and then void. And what this does is this runs all the time basically. So it will start conflicting with this one. What we can actually do is we can put the functionality of this into this function as well. So just copy everything here. Like so. And then we'll delete this function. And then if we compile the firmware again, it should be okay. And then if we flash it, then as you can see, we still have all of our RGB, all of our layer animations, or all of our layer colors basically. We will create a custom layer color function, so we can just copy this and void set layer color custom, and we will pass in the layer, and we will also want to create some variables here. So we will do an integer, and we will do a disable or enable, disable RGB effects, and we'll set this to, or we'll actually call it enable. Yeah, enable RGB effects, that will make more sense. I'm just looking at the old code I wrote and trying to explain it. So now what we're going to do is if enable RGB effects, we want to run our own code. So we will do a switch case statement. So like here. So we'll just copy all of this case, or switch, I mean. And then for the default, we won't actually use anything, but so if we enable RGB effects, and then we'll do the layer. We will do a set layer custom. We will actually make a, we'll copy this again. So set layer color, and then we'll do this as set layer color or set layer 1 effects. Now for this, just to test it out, what we can do is actually just change the hue of all the colors. So we can do hsv.h equals to, say, yeah, we'll actually do something a little bit more interesting. Plus, let's say 20. Now, if you don't know what hue is, I can show you real quickly. So if you open up GIMP here and open up its color editor here, so RGB by default is like lets you change the red, the green, and the amount of blue. So if you have all red, it'll be red, whereas the hue saturation value, for example, the first color actually changes, or the hue changes like the color, complete color. The saturation changes, as you can see, it is sliding across. It changes how, like how rich the color is. So as you can see, if we have it all the way max, it will be like super green, and if we have it all the way back, it'll just be like black and white basically. And then the value is changing how bright the color is basically. So if you crank it up, it'll be super bright, and if you put it down, it'll be like really dark. So what we're doing with hue is we're adding like 20 to it. So if we have green hue, or if our original color is green, and if we add like 20 to it or something, it'll turn blue, for example. So that's what we'll be doing. So yeah. And if we enable the switch here, actually get rid of the Bitcoin because we already have the layer as a number. And instead of doing the layer key color, we want to do the layer 1 effects, like so. And so if the RGB is enabled, we also want to do an else. So if the RGB is disabled, what we actually want to do is copy all of this again. So copy this and get rid of the bit yoke, and then just set the layer here, and then just gonna format it a little bit nicer. And I think I forgot semicolon or something. Yeah, so there should be another semicolon here, or what you call it, the bracket. So yeah, And then for this, we don't actually want any default statement, so we'll just leave it blank. And we're just using the standard layer color that is predefined here. And instead of doing all of this, well, first of all, we will check if the keyboard needs to be off. So if RGB matrix get flags, oops, equals LED, oops, flag none. So this will be basically like a black keyboard basically. So when your keyboard goes into standby, you don't want the RGBs to still, you know, show. Or if you wanted that feature, actually, you could just leave it out, you know. And then what we're gonna do, if this is set, we are gonna set all the RGB LEDs to none basically. Set color all, and then we're gonna set it to 0, 0, 0, which is null, and then else we are going to, oh yeah, so this is the, yeah, I could have just copied it from here. I actually will, because I might have mistyped something, so this way it guarantees that it's correct. And then if or else we want to set the RGBs, so set the custom RGB here, and we will pass in the layer. So which layer are we meant to be on currently? And then we can just disable all of this. And if we compile it, hopefully it should be okay. All right. And if we program it, everything should still be the same. So as you can see, I can still change colors and all that stuff. And so now, what if we enable the RGB effects? All right, so let's make that. All right. And so, as you can see, this is my layer 1 color at the moment. It's like green, red, and then yellow at the bottom. So if I flash the keyboard, this should change now. Now, as you can see, the green is now turned to blue, the red is turned to orange, and the orange turned to green. So now what we want to do is to enable these with the key press. So go back to the top of your file where you have your custom keycodes, and we will put in a custom keycode here. We will put in, say, RGB, or yeah, let's just call it LEDs animation enable. Then just copy that and put it into wherever you want on your keyboard. On my keyboard, I'm going to go over to my macros layer, and I'm going to put it on my equals key. So there we go. Now every time we press an equals key, it will generate our custom key code. And so to, oops. And so to use that custom key code, we want to scroll all the way down to our process record user function. Scroll all the way down. Just before this, what I want to do is, I'm just going to paste it here for the time being, and we want to copy this whole case statement. and then just replace this one with our custom key code, and we want to disable this as well since we don't want to send a macro. This will just comment this as RGB animations enable, and then what I want to do is set our function, or set our RGB effects. We want to toggle this, so RGB effects equals the opposite of RGB effects basically. So this will switch it up nicely, and we'll actually set the default value of this to 0, so that way they are disabled by default, and then we can flash the firmware and hopefully everything is okay. And as you can see, our RGB layer is like this, but if we enable RGB with this, it changes. You can see disable, enable, disable, enable. So that is going to be the basis of our animations. Yeah, so what's next is we want to do some like more interesting, so like actually a proper, I'll just put this above here, and we'll perform an animation now. So what this does is it goes through each LED. So we have like around 40 LEDs or so, and so we can put in the counter here. So int LED counter equals 0, and what we can do is just flash one LED. So if LED counter equals I is the current LED that we're looping through. What we'll do is actually set the HSV and then the value to 100. What this will do is it will lower the LED. And then we also want to check if the LED counter is greater or equal to driver total. So if it is, we want to set the LED counter back to 0. And then we want to increase the LED counter outside the loop. So, so LED counter plus plus, and then we can actually put this outside the loop as well, so this way the code is a little bit more efficient. Alright, so what this will do is it should only blink one color per cycle basically, or per full RGB refresh. So that's that, and let's compile that and hopefully there's no errors. Alright, and then let's enable it, and then as you can see we have the colors kind of, the light brightness of the colors decreasing in the random spots. Now at the moment this is random because we don't have any delay. What should happen is it goes from here to here to here to here to here, and then to here to here to here. But because this function is running a lot faster than what the LED controller basically can handle, we're skipping LEDs. So our next objective is to create a delay, so that way we can create proper animations that look exactly as we want and that don't skip keys. we'll create two values here. So we'll create an RGB effects delay. This will be the amount of delay that we want to use. We'll set this to 1 currently. Then we want to create an RGB effects delay and call it current count. Then we're going to scroll down to our function here, where we set the custom layer, and inside the custom we need to check for a delay. So now we also want another variable here, and I'll talk about this one later, previous RGB counter, and we'll set this to -100, so that way, because we'll be matching this against a value later on, we want to do if previous RGB counter not equal, and then this is a kind of baked in value here. This is the G RGB counters tick. So this is basically the frame rate of the counters. So this is kind of like an FPS if you're playing games or whatever. So if this is not the same as the previous counter, what we want to do is update the previous counter to equal this value. And then we want to check if our RGB effects delay current count is less than our RGB effects delay, basically. And if that's the case, we want to increase the RGB effects delay current count. So this means if our predefined delay is less than the ticks, we need to increase the count, and then that way we can display the animations properly. So if this is less than that, we do that, and then else we need to reset it. So RGB delay current count, we'll reset it back to 0, because that means we have waited long enough, and then we can render. So here we'll actually do an int change equals 0, and here we will set the change, because we want to change the effects, we want to set it to 1. And so here the code will still be the same, because every time we do have to, each time so each time this function is called, we are required to render like the RGB, we're required to set it. If we do not set it, it will be yellow. So basically the whole screen, the whole keyboard will turn yellow for a brief second if we do not reset it. So that's why we need that. And so everything else is fine. We actually need to pass in the change into these functions as well. So change, and then we will need to update our effects layer. Now or int, yeah, so make sure you put an int. Now the reason we pass in the change is because when we change, we want to update the state. So in this case, we want to update our LED counter state. So if change then we want to just enclose everything inside change, like so. Alright, and we can render, or we can compile this, so you can see the LEDs, they're still like fairly random, and this because we need to increase the delay. So at the moment we have the delay as 1. Now what I have found out through testing is that the minimum delay should be 12. So this works well for me. And to increase and decrease the delay, we also can do this with keys. So LEDs delay increase. Now make sure you put in a comma here as well. And then LEDs delay decrease, like so. Just copy one of these, then go to our macros layer, and I am actually going to set this one to the key below, because this is the equal sign, so basically the plus. I'll set it to here, and then oops, then this one will be the increase, like so, and then the minus key will be the decrease, like so. Then I'll just shift these over a little bit so it looks a little bit better. And then we also need to make our states for, or handle the custom key codes, so like the same here. And we will copy this and paste it twice, and then do this as a decrease, like so. Alright, and what we want here is the delay, so whatever we called it, or is it, yeah, RGB effects delay. We want to increase that here, and we will increase it by 5, because increasing it by 1 is like, it doesn't really show up, you know, as well. And then here we do the same thing but decrease it by 5, and then we will also check if RGB effects delay is less than 12, so our minimum value, we want to set it to 12. And then we can compile this and see how it looks and enable the animations. Now I changed it to this keyboard here, and we should see, yeah, we should see them going across. Now it will speed up in a second once it kind of launches all of its functions inside the firmware. So we should see it going fairly quick across the screen. Yeah, so there we go. It loaded up all its functions or whatever, so now you can see it's going fairly quick. Then to increase the delay, we can just press this a bunch of times. As you can see, it is going relatively slow now. There. And you can also decrease, and it'll be back to what it was before. Now, if you looked at the code a good bit, you might have seen here this delay milliseconds function. You can technically use that here. Where is it? So instead of using our delay, you can just literally put it here. But the problem with this is this delay function freezes the keyboard. So if you set this delay to very, very high and you type on the keyboard, the keys that you press won't actually come up because the delay is like hogging up basically the OS. So this is why we need to use we needed to create our own kind of fake delay to do that. So yeah, on my profile you might have seen that when I'm increasing and decreasing the delay, there's also LEDs. The 3 small LEDs are flashing. So if you want to do that, it's actually pretty straightforward. We can copy the function from here. So ErgoDox blink all LEDs, and then we can just put it here like so. And then to just enable the right LED, so for the increase actually it will be the 3rd LED, so that way it looks like, you know, it gives you visual feedback that you pressed the key properly. What you can do is just enable the right LED, and then we put in a delay of 20 milliseconds. Now delay here is fine because, you know, you won't really be typing super fast after you enable the animations and whatnot. So delay here is okay. Otherwise this will blink too fast. And it's the same for the minus. So just like so. And then compile that, and hopefully it compiles okay. Then once that's done, I will flash the keyboard with the firmware. Nice. And then I will enable the animation, and you can see there, and you should see it starting to go across here like so. And then to make it slower, you can see the LED here is turning on, or yeah, and then make it faster, the other LED is turning on as well, which is pretty cool. So you can see it running here. There we go. Then speed it up, or slow it down, I mean. And there we go. So that's that. Now so this is basically the kind of basics done for now. Now we can go into some more interesting effects. So how I managed to do the effects is actually by using a sequence. So now this will be an array, and what this means is which LEDs should be on at a given time, basically. So what these numbers mean is actually the LED code, or the LED number of our keyboard. So this is LED number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And then this starts at 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and so on. Goes like that. So in our sequence, we want to display 28 first. So 28, 27, 26, 25, 24, and then 0, 1, 2, 3, 4. And so to get this working, we also need a counter. So int number sequence key counter equal 0. Because we want to display the starting LED first, then this one, that one, that one, and so on. So inside our layer effects, what we want to do is, instead of doing this, we can do an if I is equal to our number key sequence and then the number key sequence counter. So if I is this number this time, then we want to do something with the LED. So in this case, we can just do HSV-H, and then we'll say subtract minus 100 from the current HSV value. You might also want to check if HSV.H is less than, let's say, less than 10. Then what we want to set is just the kind of the lowest value possible, because you don't want this HSV-H to go like below 0 basically, because these HSV values they range from 0 to 255, and if you go below 0 you might like damage the firmware and so on, or it'll crash or whatever. And so yeah, we'll try that. And inside our change function, we'll also need to increase the num key count ++, and then we'll also need to check if it went too high. So to do this, we can do if num key sequence counter is greater or equal to size of our sequence, so number key sequence, and then we want to divide this by size of an integer, because this will give the size of basically all of like this, and then times whatever the size of the integer is. So usually it's 4, but like that's not really guaranteed on all systems, but you could technically hard code it if you knew what this was, but this is just a safer way of doing it. So anyway, if this is greater than our number key sequence, what we want to do is reset it. So num key sequence counter equals 0. Now if you wanted to, you could also set this as whatever this count is, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you could set this to greater or equal to 9 and it'll be fine, but I just did it this way because I'll be changing this sequence counter later, so you guys can see like the different animations that are possible. And so that should be all that we need to do. So let's compile that. Okay, we have some errors. Oh yeah, my bad. If you actually declare your arrays properly, this will work. Yeah, so if you write your code properly. That's a good that's a good strat to get it working. So let's flash the keyboard there again. Great. And then if we enable the animations, we should see that they are going across, and then should be 8, 9, 0, and then should be back to 1. Okay, that was a bit slow, don't know why. It should be back like straight away. Alright, well I guess it works anyway, it is grand. Alright, there we go, so we just needed to speed up a little bit. Then we can slow it down. Like so. So yeah, that's how you do animations. And then if you want to do more, so for example, if you want to do the... So I'll throw in a cool one here. So this is like gonna be the snake that you'll see. So let's throw in that, and we'll call this int snake write sequence. Like so. Now what this animation will do is basically start off here, go down, like so, then go back, and then it just repeats like so. Now, to get the sequence, you just literally have to know which key you want to press next. So you can just count them. That's how I did this. And then just created this nicely manually. And then what you want to do is int, then just copy this and call it a count. And we set it to 0. And then we basically just want to do the same thing. Since you can have both of these animations running at the same time. That's grand. And see, snake sequence. Like so, like so. And then here we will change the brightness. Instead. And we'll just set it to 100 as before. And then we wanna update the snake sequence count. So update it here. And copy this if statement, because it'll be basically the same thing. Make sure all these are inside the change if statement. So size of num keys, the snake count, size of int, and then we want to set it back to 0. Alright, so this should be okay. And let us see. So flash the keyboard. And then enable the animations. And you can see it is going across. So I'll give it a few moments here so that it speeds up. And then at the same time you can see the our number keys animation going across as well. So which is pretty cool. Yeah, and there we go, we have the snake going across, down. That's pretty cool. And then we can slow it down so we can take a look at it a little bit better. So yeah, pretty cool. And so for the animations you can have like as many, variables as you need here. You can like have a variable for the hue that counts the hue or whatever. So yeah, let's actually quickly do that. So int, we'll do it for the snake as well. So int snake hue equals, we'll set the hue default as 0, and in our update function, so in our change function, we want to increase the hue by let's say by, well, the only possible errors are 255, so let's say increase it by 20. How about that? Let's increase it by 20, and then we also need to check if it becomes greater than, so if that becomes greater or equal to 255, we want to set it to 0 or whatever the default value we want. And so yeah, then up here for the snake we can change the hue as well. So instead of changing, yeah, so actually the brightness, I want to set this to 255, and the hsv.h, I want to change it to our hue. So this way we will have a nice colorful snake. The hsv dot, we'll leave the saturation as is, because I kind of like how the saturation of the keys looks like by default. So this should be a kind of rainbow snake, sort of. So we'll see how it looks like. Alright, so let's flash the firmware. And let's enable animations. Okay, so as you can see, the color is slowly going up. Yeah, so it's at here now, it's purple. When this updates faster, it'll be a lot nicer to look at, so we'll just wait for it a little bit. Alright, there we go. Yeah, so you can see it's like sort of RGB snake. Then if we slow it down a little bit. Now sometimes it comes up as like the same color as the keys, so you can't see it, but yeah, it is pretty good. That would be kind of how you would make some nice RGB effects, or kind of like rainbow effects or whatever. So at the moment we only have one layer kind of done, and the power of this is that we can do animations for the second layer, different animations for the third layer. So let's make some animations for my symbols key, or symbols layer. So what you want to do is you want to basically kind of copy most of this function, since we'll be doing pretty much the same thing, and we just want to disable or just remove all these for now, and remove all of these. Alright, and we'll change it to layer 2 effects. Then inside our set layer custom, or oops, yeah, so layer 2 effects, and we want to pass in the change as well, since all of your custom layer effects will need to use the change. And so for this case I am going to give it a sequence that changes all of the letters. So this sequence will go across this way, like so, I think. Yeah, so it will go across like this way, which will look pretty cool. So I already kind of did this, so we'll keep everything here. So int all letters sequence, then don't forget the brackets, equals like this, don't forget the semicolon, and then we'll also need a counter for this as well. Oops. And so we'll copy something from here, so let's copy this and paste it into here. So if snake sequence, instead of snake sequence we're using the letters sequence. So letter sequence, count, counter, alright. Yeah, that's fine. Okay. Then we want to change the, let's say, how about change the saturation to 255. Then we'll change the hue equals to, basically we want to make it like super bright. And we want to change the hue a little bit, so we'll do, let's say, plus 20. Let's see if that comes up. And since we're adding here, we want to check if HSV is greater, oops, come on, nope, wrong one, greater or equal to 255. And if it is, we just want to set it to, say, 254. And then for the change, we want to update this counter, so plus plus, and then we want to copy over one of these, since we need to reset it. And then size of all letter sequence. Alright, save that and let's compile. Okay, so there's some error here. Error. So it doesn't like the... Oh yeah, my bad. The hell was I thinking? Yeah, so change it. Don't know, I was thinking of something else clearly instead of the code. And then anyway, let us flash it. Cool. And then let us enable the effects. And so when we are on this layer, you should see somewhere that it is changing. I might have put it in the wrong place, hang on. If enable RGB effects. Yeah, so it should be in the right place. Oh yeah, I think I saw it there. Okay, this one's kind of hard to see. So what I'll do is I'll just make it a little bit easier to see by basically turning off the lights. So we'll set the value to 10. So this way it'll be a lot easier to see the effects in action, and you just kind of want to play around with this, you know, making your own custom animations and all that kind of good stuff. Alright, enable that. And yeah, so there we go. You can see it moving slowly across here. And it should go back over to here. and then go to A. So yeah, that's pretty cool. Then once you switch layer, you'll have your own animations for the layer, and then just disable the animations if you want altogether. So that way it's like nice and stuff. Now that the animations are up to speed, you can see that it's going like fairly quickly across the board. So pretty cool. And then you can like slow it down as well a little bit. So now we can see it a little bit better. Yeah, so that's it for this video, I'd say. Once I figure out how to do more kind of custom effects now, and I don't know, other interesting stuff with this keyboard, I will, or with the QMK firmware, I'll make another video. So yeah, thanks for watching and bye bye.